Hello, in today's lesson we're going to be looking at an introduction to waves. There's two different sorts of waves. We've got transverse waves and longitudinal waves. Now all waves transfer energy from one place to another and they don't transfer any matter. No particles are actually transferred from one place to another. There's lots of things all waves have in common, being able to be reflected or refracted. But there's a few key words that we need to look at today. So we need to be able to identify transverse and longitudinal, and we need to understand the terms frequency and amplitude, and also going to look at how we can calculate frequency. You also need to understand the terms crest and trough and compression and rarefaction. Right, so in front of me I've got this slinky spring, and a slinky spring is very good at demonstrating a mechanical wave. And the good thing about mechanical waves is they can be both transverse and longitudinal. So to start with, I'm going to show you a transverse wave and then a longitudinal wave. Now the thing with the transverse wave, I'm moving my hand from side to side. And this is causing the disturbance in the slinky spring also side to side. So the wave has a direction which is away from me to you, and then it reflects and comes back. But actually the disturbance of the particles in the spring are moving perpendicular. With the longitudinal wave, it's like a pulse that goes down the spring, and it's the particles in the waves are actually oscillating, moving backwards and forwards in the same direction as the wave. So we say the oscillations are parallel. So transverse, the oscillations are perpendicular. So longitudinal, the vibrations or oscillations are parallel to the direction of the wave.
First thing I'm going to talk about is amplitude of a wave. Now, an amplitude of the wave is its maximum displacement from its resting point. So with this spring, a resting point, well, the resting point would just be a straight line. Now, as I move my hand side to side with a small amplitude, with a small force, you can see you get small waves. As I move my hand side to side with a greater force, moving my hand side to side further, we get a larger amplitude. The faster I move my hand side to side, the greater the frequency. Frequency is the number of waves that pass a point every second. Looking at this wave, we can see crests and troughs. A crest is the top of a wave and a trough is the bottom of the wave. The distance from one crest to the next crest is called the wavelength, and therefore as I move my hand faster, I will actually have a shorter wavelength but a higher frequency. I'm going to demonstrate the same things with the longitudinal wave now. So the longitudinal wave is like a pressure wave. Each of the compressions that go through are called exactly that, just a compression. The space between the compressions is called the rarefaction. Now, the distance from one compression to the next compression is called a wavelength, just as in the transverse wave. Exactly the same as before. Greater force that I move, or the greater distance my hand moves through, the greater the amplitude of the wave, and the faster I move my hand, the higher the frequency.
So in today's lesson we looked at the two types of waves. So we looked at transverse, where the vibrations or oscillations were perpendicular to the direction of energy transfer, and we looked at longitudinal, where we saw that the oscillations were parallel to the direction of energy transfer. We should also be familiar with the keywords frequency and amplitude, and to be able to identify the crests, troughs, compressions and rarefactions. So now that you've seen my demonstrations, it's time for you to go and do some work. Goodbye.